spaces represent a part of the truth. But if we draw the whole truth, it's really hard to see it. But if we draw all these pieces that we could look at independently, and then we have the time to integrate them. And it's the same approach. So a big part of dealing with problem solving is to open up that space in various ways through various techniques. Now, one way is to use this completely intuitive approach. And the problem with that is it leads to disastrous results. For example, I'm tutoring this gal, and it's in physics, and we had talked previously, a few days ago, about point charges, positive and negative, and if you have a positive charge and you have a negative charge over here, opposites are going to attract, so they're going to move toward each other. Fine. Now that's not a general rule for other things that are kind of like positives and negatives. That's for positive and negatively charged particles. So we're talking about wires and magnetic fields and all that kind of jazz, and I talk about a wire with a current going in and a current going out of the paper, which kind of looks like opposite things. And I say, will they attract each other, these two wires, or will they repel? And she says, oh, well, they're going to attract. And I said, well, why? Because she didn't think about it. We talked about the current, we talked about the magnetic field, we talked about the force, we talked about the right-hand rule that tells you the direction, and she just says, no, they'll attract. So what did she do? I asked her why, because she got it wrong. Okay, they're going to repel. She says, well, you know, those charges did it. That way, the wire should too. And there's some connection. There are charges moving through the wire, but it's a completely different system. And she's intelligent, it's just she hates physics, so she's just hoping it's a Hail Mary type of thing. So here's a way that you're really maintaining lots of space in your consciousness, but you're getting the answer wrong. So I mentioned to her a technique that does work really well. It's just as short, but it works much more reliably. We had just done a problem in which two wires were going, had currents going in the same direction. And when that was the case, they were attractive. And now we're switching it. Now what happens is in some systems, in physics and in organic chemistry, you have systems that are binary. What that means is that you have a series of variables. You have 2, 3, 4 variables. But the choices are either zeros or ones. One way or the other. One way or the other. So when you change one thing, then the result changes. And this is a wonderful rule. This always works. As long as these are relevant variables, variables that are in the equation that determine what's going on, relevant to the chemical structure of what's going on, then you've got it. And so we just saw how it worked, and now we switched one thing. You can do that in organic chemistry with configurations, with all sorts of cool stuff, which I won't bore you with, and you can do it in a whole range for physics. So that's kind of a trick that does work. But there are things that absolutely are not intuitive. Most of physics is not intuitive. That's why Isaac Newton was such a cool guy, because he figured out how the stuff works. And other folks didn't. They thought that a cannonball goes through the air, runs out of energy, and then drops straight down instead of having a parabolic path. And he worked the whole thing out. So it's not intuitive. Acceleration is not intuitive. Almost everybody that hasn't taken physics in high school, and lots of people haven't, and even those that have, don't understand the difference between velocity and acceleration because it's not an intuitive concept. So what you have to do in those cases is you have to actually work it out through a rigorous means. But we got this limited consciousness, so how do we deal with that? Well, what we do is we come up with subroutines. So you can take a problem and you can kind of break it down into pieces. Now, when you look at a problem, what happens is, unless you have a lot of experience with that problem, a lot of experience with physics, you frequently don't know how the fuck to get the answer, or even what equation to use. You might have some idea. So people just freak out because they're so used to looking at something, memorizing it, and saying, that's how you do it. And with physics, there's so many different ways you could rearrange problems with different concepts from different chapters that you can't do intuitive stuff. You actually have to think. So what do? What you do is you start to break it down, and you look at the variables, and you say, okay, these are the variables, and you think, what equations do I know with those variables? And the best thing to do is not to think. Now here's why you don't want to think. You just want to set it up and not get an idea of what you're supposed to do. Because if you're wrong, it's going to be super hard to turn around. Because what happens is, the way we really think is not by working it out and figuring it out. Somebody crawls in through the back of our head and goes, bop, 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 bop. What about this? And you go, yes, that's it. That's how it works. But if you think, okay, without a lot of experience, that you can say, oh, I recognize this, let's do it this way, and you lock onto that, you almost always will not solve the problem. Because you will expect one thing and you get another, and very few people can turn around. So the best thing to do is just take this break, be like Zen-like, just lay it all out, and then the most amazing thing happens. Now I know I have some experience doing this, but I've seen it with students too. If you give yourself that space and don't rush yourself about thinking about it, you can start to work into the problem, and sometimes it's all there. I've seen students that use this technique, and all of a sudden they just know how to do the whole problem. They may not know how to do it in detail. They might not all be able to explain it, but something in the back of the head goes bim, bim, bim. They see it. And if they don't see it, they can take steps toward it. But if they think too hard, I got a long video, so I must be at 15 minutes because the screen just went blank. But if they think about it, what happens is they get all jammed up. And the reason is, it's the same old concept, is that if you take too much conscious control, you use up space. And once you use up that space, all this other stuff beneath there, which is there to help you, gets blocked out. That's why when you write prose or poetry, you basically write from the heart. It spills out when you do your first draft. You don't damn construct the thing, because the part that writes that is beneath the surface, and then later on when you're going to be tweaking it, that's the little stuff. So it goes beyond just science and all, but anyway, I've gone a little bit longer than I wanted to. Obviously, this is something that I've thought about a lot, and it's interesting to me. I hope it's a little bit interesting to you.